Okay, so today we're gonna again expand on the notion of relation and function, right? I've already shown you how they differ. Um, when when you're given a table of values or when you're given the coordinates, right? So you can kind of know when it is not a function. But today we're gonna talk about the graph of a relation. And compare that to a graph of a function. And we can actually look at the graph and come to the same conclusion. Okay, so I guess before we talk about that stuff, let's just refresh our memory. So my question to you is, what is the key difference between a relation and a function? Okay, what is the key difference? So think about that. Um, or maybe draw something out, give me an example, right? Just do something. Hopefully that will answer this question. So I'm going to proceed. You can pause and think about it. So the key difference is that when you have a function, okay, a function, um, each element in your domain, right, will be matched to exactly one element in your range. What do I mean by that, right? So let's just go back to that my classic example. So let's say this is the list of my students. So let's just call this X, right? This is my domain. I have student, I'm just gonna, yeah, because, okay, you know what? I'm actually gonna write the words first before I draw the circle. So let's say you have student one, student one, student two, right? Student three. I don't want to come up with the names today because just takes me a while to really think about who to choose. So let's just let's just pick some random students. Let's say you have 100, 80, and 70, okay, or something. Okay. Now, right? So if this is a function, then each element in your domain should get mapped to exactly one element in your range. Okay, so this is your range. Okay, so let's just call this y. This is your range. Exactly one element, right? You cannot have student one. This cannot happen. Student one cannot get a grade of 80 and 100 at the same time. Okay, this is not a function. It's a relation, but it's not a function. Okay, so let's say student two gets 70 and then student three gets 80. This is a function. Okay. Um, Now sometimes this might also be possible. So let's say if I erase this, and let's say if I say student one also got 80. So no one got 100. Um, okay, so student one and student three got 80. It's possible to have a y value that's associated to two different x values. Okay, that's fine. There's nothing wrong with it. There's, it's possible that two different students in a class, it's possible for them to have the same grade, right? But one student cannot have two different grades at the same time. Okay, so so the y value can be shared between two x values, but the x value cannot be shared between two y values. Okay, so again, let me emphasize it that when you have a function, right, the emphasis over here is that each element in your domain will be mapped exactly to one element in your range. Okay, that's not true for the range. Okay, in the range, each element may not necessarily be mapped to exactly one element in your domain, right? Which is what you see over here, right? So the inverse is not true, but right? But each element in your X has to be mapped to exactly one element in your range. Okay, so that's the key point. Okay, um, so now um, let's just continue. So here we have a table that represents whole numbers. By whole numbers, you mean like positive whole numbers. Okay, that's the that's what it actually means. So whenever we talk about whole numbers, we talk about it automatically implies that we're talking about positive whole numbers. Okay, so this is your domain, right? This is your dependent value domain, whatever you want to call it, and this is your range. Okay, so the relationship over here is that you have to double your x values, right? So one times two is two, two times two is four, right? So you double um, your x values to get the y values. Okay, so that's a relation, but this is also a function, right? This is also a function because, as you can see, when you double zero, you're only going to get zero. You cannot get zero and two. Okay, so each element in your domain is associated to exactly one element in your range. Okay, so this is a relation, but it's also a function. Now, obviously, the table continues forever, right? So you can go to 5 and then 6 and then 7. So the table continues for all whole numbers, but you don't have to draw the whole table, right? So that kind of gives you this kind over here kind of gives you an idea of what we're talking about. The domain, right? This is your domain. Okay, this is your domain. Um, Let me write this out for you. Also, guys, I'm going to be posting the printed version of the notes. Not printed version, I should say. I'm going to be posting blank copies of the notes that I would recommend just printing it off and then following what I am doing over here as opposed to just copying everything down. And again, this is all given in your textbook as well. So I don't want you to, write everything by hand, unless if you want to, then again summarize what's important, right? And it's not that long, but again, like if it's possible to print the notes, um, don't hesitate to do that. Okay, so this is my domain, and this over here, let's just you know in blue over here, this is my range. Okay, range is the range is a set of even whole numbers. Okay, even whole numbers. What do they mean by that? As you can see, because we're multiplying everything by 2, your output will always be an even number. Okay, so like 2, 4, 6, 8, and a whole because they're all positive as well. Okay, so by whole number we mean positive numbers, right? That's the definition that um, the mathematicians, I guess, have chosen. Anyway, so so this is one way to represent a function. Okay, so this is your function. So using a table of values. So this is one way that you can represent your function, right? Using the table of values. But another way that you can represent your function is using a graph. Okay, this is also very common. So again, your domain is still the same, right? All the whole numbers. So uh, again, 1 is included here, right? So 1, 2, um, all the way up to infinity, right? So and then what you have to do is just just by looking at the table, I guess, right? When x is equals to 0, y is 0, so you put a dot over here. When x is equals to 1, y is equals to 2, right? When x is equals to 2, y is equals to 4. So that's how they came up with the dots over here, okay? So that shouldn't be too difficult. But now here's the thing, okay? Um, how would the graph change if x and y were real numbers? Okay, so now, this is something we did at the beginning of the year. What do we mean by real numbers? Remember, real numbers will include everything, okay? By that, I mean you could include half, you could include 1/3. You're going to have to include everything up here. So all your decimals, all the ugly numbers, right? So when if this is a graph of real numbers, then you're not gonna have this space in between, right? You're not. So this is, for example, this is 1 over here, right? And then there's a space between the value that your function took at 0 and the value that your function took at 1, right? Because that's how your table is arranged. But if this was real numbers, then everything will be connected. Okay, everything will be connected like this. Okay, that's how it will change the graph. Okay, when we include real numbers, that means there is no gap. Okay, because this will include 0.1, 0.011, 0.001, right? Like everything will be in there, all the decimals, everything. So there will not be a gap. So you're just gonna have to connect your dots. Okay, so that's how it will change. How can you tell the domain and range from the graph? Okay, how can you tell a domain and range? Your domain will always be your x-axis. Okay, so this here is your domain. Okay, domain will always be your x-axis. Okay, and your y-axis, right, this will always be your range. Okay, so this is your range. So that's how you can, and this is like this is not applicable to this one example. That's always the case. Okay, your domain will always be your x-axis. Okay, and your range will always be your y values. Okay, so kind of like your y values. Okay, so how do you find the domain in this case? Okay, so one way of finding domain, guys, is domain will always be expressed in terms of x. It will start with the minimum x value. Okay, here I'm gonna have to use this squiggly brackets because because we have gaps in between. Okay, so I don't know why my parentheses aren't looking that nice. Anyway, okay, so let's just go with what I have. So the first x value is 0, so that's the minimum, and then the next one is 1, and then it's 2, and then it goes on forever and ever and ever. So I'm going to put 3 dots. Okay, so that's my domain. Now my range, right? My range, let me just do the range over here. Okay, my range, again, minimum y value. My minimum y value is 0, and it has to it's increasing now by 2, right? So the next one is 2, and then it's 4, and then it goes on forever and ever and ever. So I'm just going to put 3 dots to illustrate that. Okay, so that's your range. Okay, so domain and range, you're gonna have to look at your x-axis, find the minimum value, right, for domain, right? Your minimum x value over here is 0, and your maximum is, there's no maximum, right? Because it's going to go all the way to infinity. Same thing for your domain, right? The minimum y value for your domain is 0, but there is no maximum. Okay, so that's why I'm putting 3 dots over here. Okay, so we're going to talk about domain and range shortly. Okay, so let's just kind of like introduce the idea, but then I'm going to give you more examples and hopefully will make a little bit more sense a little later. Okay, so now this is important. Okay, so you can read the definition on your own. I'm just going to give you an example. So the vertical line test is what will help you distinguish a function from a relation. Okay, so let's say if you have a graph of a function. Okay, so let's say this is x, this is y. Eventually you're going to work with a function that kind of looks like this. Okay, so you know what, let me just, yeah, so something like this. Okay, so this is what you will do in 30-1. Okay, I know it looks complicated, but don't worry about it. Okay, so it will make more sense when you do 30-1. Now my question to you is this a function or not? Okay, so one way to check if it's a function is you have to draw a vertical line. It's kind of like place your ruler on the graph like this, and then move this ruler. I can't really do it up here, but like move it, so you, and then see if there's a point in the graph where so maybe my graph isn't drawn properly. So let me draw this a little better. Okay, so something like this. Something like this. Okay, so now is there a point in this graph where if I do a vertical line test, every time you do a vertical line test, there should only be one intersection. Okay, for example, right over here, there's only one intersection. Even over here, there's only one intersection. Okay, as long as you have one intersection, then this is a function. Okay, this is a function. Now, what is not a function? Okay, so if this is a function, what is not a function? So um, let me erase this partially. Oh, this is gonna take forever. Okay, I think it's fine. Anyway, so let me give you another example. So this is a function. Okay, by check mark, I mean this is a function. Now this is not a function. Why? So if you have something like this, let's say, okay, so something let's see, something that goes up and then comes down and then does this. Okay, or you know what, let me change this. What if we just do this? Okay, so this looks like a neat relation, but this is not a function. Why? Because if I do my vertical line test, okay, I'm intersecting my graph, right? This is my graph in red over here. I'm intersecting my graph at two different points, okay? So as soon as you intersect your graph at two different points, this is no longer a function, okay? So I'm going to put a cross over here. So this means uh, function. This is a function, okay? Function. And this is, right? This is not, by the cross, I mean not a function. Okay, not a function. Why? Because when I do my vertical line test, right, when I draw a vertical line, it is intersecting this graph at two. If it intersects your graph at more than one point, it's not a function. So if you have something like, let's say, what if I make it even worse? So what if I do something like this and this? Okay, now as you can see over here, this will at times intersect at three different places, right? One, two, three. So this is even worse, okay? So that means now for each x value, right? for each x value, you have 3 different y values. That cannot be possible. Remember, definition of a function is for each x value, you can only have one y value, okay? For each x value, you can only have exactly one y value, right? Exactly. Now over here, it's different, right? So this is one way to kind of like convince yourself that it's a function. Just draw a vertical line and make sure that it intersects your graph only once. If it intersects more than once, then it's not a function. Okay, so let's do a few examples to understand this. So the question is, which of the which of these graphs represents a function? So you have a graph over here, okay? But as you can see, if I draw my vertical line over here, I don't, let me change the color. So if I draw my vertical line over here, I don't have a problem. But for it to be a function, it has to satisfy the vertical line test everywhere in the domain, okay? Everywhere. So here it's okay, right? But you have to be clever. You have to find points where it doesn't work. It doesn't work over here, right? It doesn't work over here. If I could draw a straight line, that would be awesome, but I don't think I can. So we're just gonna have to go with this. Oh, I did. I don't know how I did that. Anyway, so it's not a function because it's intersecting um, 2 different points. Here it's intersecting 3 different points. Okay, so this is not a function. Okay, now over here, if I do my vertical line test, it's gonna pass the vertical line test at every point. Okay, so this is not an issue. This is a function. Okay, it's easy. It's as easy as that. Just draw the vertical line. If it intersects 2 points, then it's not a function. And then you have to pick those those points strategically, right? Because if I do my vertical line test at this point, yes, it passes the vertical line test. But does it pass the vertical line test everywhere? No, it doesn't. It fails over here and it fails over there. As soon as it fails once, it's no longer a function. Okay. So that's I guess the key takeaway over here. So now what I'm gonna ask you to do is pause the video, try doing these 2 questions and figure out which one is a function. Okay. So if it's a function, it has to pass the vertical line test everywhere. So I'm going to continue. As you can see in part A, right? If you draw a vertical line, it doesn't matter at which point, it will always pass the vertical line test, okay? So this is good. There is no problem. It never fails. Now this one sometimes passes, right? The first point probably passes, but then the next one doesn't, right? So this is a function, this is not a function, okay? Because it fails over here, and as soon as it fails once, you don't have to continue, right? You don't have to list out every single place where it fails. As soon as it fails once, that is it, okay? So this is not a function because it failed the test, okay? At one point. So once it fails the test, at one specific point, then that's it. Okay, you don't have to check everything. But if it passes the test, then it kind of has to pass the test at every single point. Okay, as you can kind of see over here. Okay, so this is good. Okay, so I hope the vertical line test kind of makes sense. Um, now back to domain and range. Okay, so this is a different graph, right? This is a graph of real numbers. That's why there is no gap in between. Okay, so all the decimals are included in here. So how do you find the domain? Okay, so let's focus on part A. Again, guys, domain, the key thing to remember is domain is always expressed in terms of your x value. Okay, so how do you find the domain? You have to find the minimum x value and the maximum x value, and everything in between will be your domain. Okay, as long as there's no discontinuity, but you probably don't know what that means. But in your case, let's just stick with minimum x value to maximum x value. Okay, so in this case, I have a dot over here, so that means that my function stops over here, okay? It doesn't continue, right? As you can see, there is a dot over here, okay? I'm just gonna circle that. So it doesn't continue, it stops over there. Here, I don't have a dot, okay? So that means it continues, okay? So it continues, it goes up, but it also goes sideways, right? So if you think about it, there is no minimum x value, right? Because this function is going to go on forever and ever and ever. So my x value will become smaller and smaller and smaller and smaller. So there is no minimum, okay? There is no minimum, but there is a maximum, right? The maximum over here is this x value, okay? So this dot happens to be at this location. So if this is 0, this is 2, then this has to be 1, right? So that means this is 3. So my maximum x value is 3. Okay, so my x domain will always be expressed in terms of x. So x has to be less than or equals to I'm gonna put the equal sign because this dot is colored. Okay, if it, so what do I mean by colored dot? So if your dot is colored like this, that means you have to put an equal sign. Okay, but if it's open, then you don't put the equal sign underneath. Okay, so this means this could mean less than or equal to, or greater than or equal to. Okay, so depending on the situation, this one is less than or greater than. Okay, so it depends on the situation. In my case, it's less than because all the x values that I have in this function are less than 3, right? So there is no minimum, but there is a maximum. So x has to be less than or equal to 3. Okay, now for the domain, for the range, sorry, so let me use a different color. So range, same idea. Okay, I'm looking, but the only difference is now I am focusing on my y value. Okay, range is y value, so you have to focus on the minimum y value and the maximum y value. Okay, so minimum seems like it's this one, right? Because my function doesn't go underneath this, so that means y has to be, and it touches that value, right? So y has to be greater than or equals to -1. um, but is there a maximum? So yes, my function stops over here, right? My function stops over here, but my y value seems to continue up here, right? So y value on the right hand side does stop here, but on the left hand side it doesn't. It continues on forever and ever and ever, right? So is there a maximum? No, there isn't, right? So you cannot say less than or equal to something, okay? So there is no maximum, okay? So there's only one restriction. Y has to be greater than -1, okay? And that is it, okay? Now, now let's focus on the second question. Okay, so the second one is will hopefully make things a lot clearer for you. Okay, so let's just be consistent with the color. So domain, again, domain has to do with x. Okay, so I'm gonna put my x value over here, and in this case, right, as you can see, there's a dot over here and there's a dot over here. So my x value does have a minimum. It also has a maximum, right? So that means x. What's my minimum value? So x has to be greater than equal to, right? -2 is my minimum, right? So this, right? So I don't know how you guys did it, but like one way to think about, um, one way to convince yourself that x is greater than -2 using this notation, one of my teachers used to say that just look at the mouth of the alligator, right? So if the mouth of the alligator, when it points to something, that thing will always be greater than the tail end. Okay, so two, so this notation tells you that x is greater than, because the mouth of the alligator points towards x. Okay, so x is greater than equals to 2, but at the same time, it also has a maximum, right? The maximum over here is at the point 2, so it has to be less than or equal to 2. And again, the reason why we're putting equal is because the dot is shaded, okay? It's shaded. If it's non-shaded, then it would be different. And again, domain always has to do with x. Range is different, okay? So let's focus on the range now. Range, right? Is there a minimum x value? Before I put all that stuff, so let's just think about it. Is there a minimum y value, right? Because now my focus shifts from y. Yes, it seems like there is a minimum. See, because my function now is stopping on both ends. So my function, unlike this one only stopped at this end, but so it continued over there. But this one stops at both ends. So there is a minimum y value, and the value is this y value, right? Which is 0. Okay, so right, remember this, your y value is this one, right? So this value over here is 0, and then that's 1, and then 2, right? So 0. And is there a maximum y value? Yes, there is. So I'm gonna put the maximum over here. So if this is 1, right? If this is 1, then this has to be 2. And it seems like my function doesn't go beyond 2, right? So y is less than or equals to 2, and it's greater than. So it's kind of like bounded from both sides, right? It's kind of like sandwich in between. It has to be greater than 0, but it cannot be greater than, any greater than 2, right? So y is in between 0 and 2, including 0 and 2, right? Because again, your dots are shaded, okay? That's what you're gonna have to look at. Okay, so I hope the domain and range is kind of making sense. If not, let me know. Send me an email, and then I can maybe do more questions or something like that. Okay. Um, So here I want you to practice for domain and range. Okay, so pause the video, please do this. This is the last thing that you're going to do today. Okay, then you will have your homework. So please practice this. I'm going to continue. Okay, it's a nice idea to practice on your own, right? So domain, right? Domain. I'm just going to put D for domain. Okay, so domain, two dots, always has to do with X. Is there a minimum X value and a maximum X value? Look, this is my maximum X value, right? Because my function doesn't go beyond this point, okay? So that means X has to be less than or equals to, and that value, right, is 5, because if this is 2, then this has to be 1. So X is less than or equal to 5, but does it have to be greater and equal to something? Does it stop on the left-hand side? No, it doesn't. If there was a dot over here, then it would, but there is no dot, okay? So that means that I don't need this piece over here on the left, okay? There's no minimum, there's just a maximum. Now for the range, right, for the range of my function, again, that has to do with y. Is there a minimum y value or a maximum y value? So let's look at this. Okay, so it seems like this point over here, if you now change your focus from x to y. Okay, so it seems like this value over here of y is the biggest y value that the function can attain, right? Because it cannot go any higher than that, right? Cannot go any higher than that. So my maximum y value is 2, right? And you might think that my minimum y value is -3. It is true. It is true. If you're looking at it, if you're ignoring the left piece, then it is true. But there is a left piece, and the left piece continues on forever and ever and ever, right? So there is no minimum. Okay, there is no minimum. So that means you can't really put anything over here, right? You cannot say it has to be greater than 0 or something, because it does go beyond 0, or even -3, right? Some of you might say -3. So let me erase this. If you said -3, yes, you are true if you're only looking at this branch, but there's a second branch that goes on forever and ever and ever, okay? So the answer is that y has to be less than 2, and there is no minimum, okay? Now let's focus on the next one, right? So again, I'm going to use D for domain. Now domain has to do with my x values, okay? So it seems like I do have a maximum x value and I have a minimum x value, right? So it's going to be bounded between, so the minimum goes on the left. Minimum is, let me erase this to see a little better. Minimum is -3, and my maximum is 5, okay? Now for the range, do I have a minimum and a maximum? Yes, I do. So I'm going to put both this inequalities, right? So the maximum y value that my function can attain is this one, and the minimum y value is this one. Okay, so let's see what that value is. So it seems like the maximum over here is 7, right? Because again, if this is 2, then this has to be 1, right? And my minimum is 3. Okay, so minimum is 3. Okay, so in other words, right? In other words, let me kind of like summarize this. So for domain, right? Domain, this is how you find the domain. It always has to be greater than equals to your minimum value, your x, right? We're talking about your x, and less than or equal to your maximum. If there is no minimum and max, then just ignore that part. If there's no minimum, then ignore this, right? If there is no maximum, then ignore that part. Okay, so then you'll only have half of what you're supposed to have. And for the range, right? For the range, the idea is the same, right? Range has to do with your y value, so it's going to be bounded between your minimum y value, right? Y has to be bounded between your minimum and your maximum, okay? So this is how you find domain and range. And I hope this kind of made sense. If not, again, let me know, send me an email, and do the homework questions. Check your answers, right? The answers are given to you. I've even posted the solutions again, so some of you, I'm talking to my non-immersion students, right? Because you don't have the textbook, so I posted it on Google Classroom. If the textbook is too lengthy, let me know. I've posted the solutions separately, and I can also post the chapter notes from the book separately as well. If it's too lengthy and you can't download or whatever, let me know, okay? But yeah, practice, check your answers so that you know you're on the right track. And if it's not making sense, send me an email, and maybe I can make a separate video, or I could help you on Thursday, because Thursday I'm going to have office hours, and on Friday you will have your optional quiz. Okay, so that is it for today, guys. Thank you so much.